The purpose of this video is to introduce geometric sequences. We're going to be able to identify and use multiple representations, i.e. words, tables, and graphs to represent a geometric sequence, and to calculate the common ratio for a geometric sequence and use it to generate additional terms for that sequence. A geometric sequence is a special type of sequence where the ratio of every two consecutive terms is a constant. The ratio is known as the common ratio. Every term is multiplied by the common ratio, which results in the next value. So let's just do a quick example. Let's say our first term is 2 and our common ratio is 5. So what we do to generate the next number is we go 2 times 5 is 10. And then our next number is 10 times 5 is 50. And then our next number is 50 times 5, which is 250, and etc. Now, to find the common ratio, if we gave you a sequence like this, we're simply going to take the most current term and divide by the previous term. So consecutive terms, our example here would be like 50, 250. We're going to go 250 divided by 50, and that's going to give us 5 over 1, or 5, right? We can take any two consecutive terms in the sequence, right? The 10 and the 2. 10 divided by 2 equals 5, or 5 over 1. So our common ratio is 5. Let's look at a few more examples. So our first one here, here's our sequence. And the common ratio work is done here, right? We're taking 108 divided by 36, and we got 3. We're taking the 36 divided by the previous term 12 and get 3. We're taking the 12 and divided by the previous term value, which was 4, and we get 3. So that is our common ratio. Then we use it to find the next term. You're multiplying by 3. So 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 432. 432 times 3 is 1,728. If I wanted the next term, I use my calculator. I go 1,728 multiplied by 3 and get the next value. Okay? That's an example of an increasing geometric sequence. But sometimes they're decreasing. If our common ratio is a number between 0 and 1, it's going to be decreasing. So this example here is 8, 4, 2, 1, 1 half, 1 fourth. To find the common ratio, we simply do the same thing. Take the most current term and divide by the previous term. So if I did 1 fourth divided by 1 half, 1 fourth divided by 1 half, we know we change that to multiplication. 1 fourth times 2 over 1, which gives us 2 over 4, which is 1 half. If I go 1 half divided by 1, I get 1 half. If I go 1 divided by 2, 1 half. 2 divided by 4, 1 half. 4 divided by 8, 1 half. So again, for making the sequence, we're just multiplying by a half each time. So our next one here would be 1 fourth times 1 half, which would be 1/8. The next term value would be 1/8 times 1 half, which would be 1/16, and so on. Now, special note, you can have a common ratio that is a negative value. So if we took that first sequence up here and we made the common ratio -3 instead of 3, look what happens with our sequence. 4, -12, +36, -108, +432, -1728, and so on. Okay, same thing with the one that's decreasing here. We can start with the initial term. The initial value could be -8 instead of a positive number. It's negative to start with. So -8 times a half is times -1 half, +4 times -1 half, -2 times -1 half, +1 times -1 half, -1 half, -1 half times -1 half is +1 fourth, and so on. Okay. Now, when we work left to right, we're multiplying, but sometimes you'll have problems where they want you to find something to the left of a term value. And so when you go backwards, you're going to divide by the common ratio. So in this example here, what is our common ratio? Well, 320 divided by 160, that's 2 over 1, or 2, right? I could also use the 40 over the 20 is 2. I could do 20 over 10 is also 2. All right, so if I'm going this way with my sequence, 40 times 2 is 80. If I wanted to use the 160 and go backwards, I would have went 160 divided by the common ratio 2. 160 divided by 2 is 80. Now to get my initial term, I have to go backwards, right? So I'm going to go 10 divided by 2 is 5. Other way you could do this, you could ask yourself, what number multiplied by 2 gets me 10? And you could come up with 5 that way as well. Let's do a few more examples. If you want to pause the video and try these yourself and then check to see if you're right, that's a good idea. So 2, 8, 32. What's the common ratio? 32 divided by 8 equals 4 over 1. 8 divided by 2 equals 4 over 1. So our common ratio is 4. So then we're going to multiply. 32 times 4 is 128. 128 times 4 is 512. And 512 times 4 is 2,048. All right. Next one. What's our common ratio? 250 divided by 500. You're either going to get 1/2 as a fraction, or use your calculator. Go 250 divided by 500. Your calculator will say 0.50. All right. If I go next one, 500 divided by 1,000. Same thing. You're going to get either 1/2 or your calculator is going to tell you it's 0.50. So our common ratio is 1/2, or if you prefer decimals, 0.5 or 0.50. So then on your calculator, you're just going to go, okay, what are my next values? I multiply by the common ratio. So 250 times 0.5 or times 1/2 is 125. 125 times 1/2 is 62.5. 62.5 times 1/2 is 31.25. All right, one more. All right, so this time to find the common ratio, we really only have one option here. Okay, we have the 270 and the 90. So we go 270 divided by 90. All right, so 270 divided by 90 is 3 over 1. So our common ratio is 3. So 10 times 3 is 30. 270 times 3 is what? 810. Now let's look at multiple representations for our geometric sequence. So in words and context here, here's our scenario. Health officials are watching a new virus that has been spreading in Roseville. The weekly number of new cases for the past 3 weeks has been 9, 27, and 81. If this trend continues at the same growth pattern, how many new cases will we expect in Roseville 5 weeks from now? So 5 weeks from now would be week 8. All right, so what's our common ratio? Well, we can go 81 divided by 27, which is 3 or 3 over 1. We could also go 27 divided by 9, which is 3 over 1. So our common ratio is 3. So if that pattern continues, that's our trend, we're going to generate the remaining numbers in our sequence by multiplying the previous term by 3. So 81 times 3 is 243. I'm going to put it right in the table. I could also put it up here, but I'm going to put it in the table for now. Okay, 5. You're going to multiply 243 by 3, which is 729. So this was 243, 729. Our sixth value is going to be 729 times 3, which is 2,187. Our seventh term value is 2,187 times 3, which is 6,561. And then our eighth term value is 6,561 times 3, which is 19,683. All right. Now to graph these, our horizontal axis is going to be the term number. So we got the term number 1, 2, 3, 4, 5, 6, 7, 8 down here. Our vertical axis is going to be the actual term value itself. So what's the term value of term 1? It's 9. The term value of term 2 is 27, and so on. So you can see the first initial points are graphed here, and they're fairly close to the horizontal axis, 0, because the scaling for this one is going by 1,000, because we got to go all the way up to almost 20,000. All right, so let's see what happens. When you go for term 4, 243, that's way down there still, right? And I'm not going to be perfect. I'm doing this on the computer here screen, so I'm not going to be perfect, but you get the idea. You get somewhere in that ballpark. That should just be 1 point. Okay, then 5, 729. So I'm about there, maybe a little higher. Okay, then I go to 6. I go all the way up to 2,187. So maybe that's about there. And 7, 6,500 and something here. So 6,500 something's about right here. Okay. Again, there's just one point there. And then number 8, term 8, go all the way up to 19,683. So it jumps all the way up to here. Okay. So we have our graph. We're going to have discrete points. We're not going to connect all the points because with your terms in a sequence, you can't have a partial term. So we're not going to have term 1.5. We're not going to have term 2.3. So it's term 1, 2, 3, 4, 5, 6, 7, 8. That's why this discrete graph, we don't connect the dots. And then how do you see the common ratio in the graph? Well, the amount that is increasing on the y-axis, how much is going up each time, that is tripling. So you start to see it's going up 3 times as fast. So you can imagine this is going to really take off. If this pattern continued, it would just take off and go up, 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 and away if the pattern continued. So that's how you represent a geometric sequence, multiple representations, words, a table, and a graph. Hope this video helps. Have a great day, and thanks for watching.